Let's uncover the magical secrets of the colors of light. The world we see with our eyes is filled with light. However, it's not just white light like sunlight. How are the diverse colors of a rainbow created? The secret lies in the wavelength of light. Light is a type of electromagnetic wave and it vibrates like a wave. The amplitude and frequency of this wave are key factors that determine the brightness and color of light. Amplitude. This indicates the height of the light wave and is related to brightness. The greater the amplitude, the brighter the light appears. Frequency. This indicates the time it takes for one cycle of the light wave to pass and is related to color. The higher the frequency, the closer the color is to blue, and the lower the frequency, the closer the color is to red. Visible light is the light that we can see with our eyes, and it has wavelengths ranging from about 380 nanometers to 720 nanometers. Within this range, as the wavelength shortens, the light changes from blue to violet, and as the wavelength lengthens, the light changes from red to orange. Interestingly, the color we see an object as is the color of the light that it reflects, not absorbs. For example, a red apple appears red because it absorbs all other colors of light except red, which it reflects. The three primary colors of light are red, green, and blue. By mixing these three colors, millions of different colors can be created. For example, mixing red and green creates yellow, mixing red and blue creates purple, and mixing green and blue creates cyan. The colors of light make our surrounding world richer and more beautiful. Just like a magician's cloak that creates various colors, continue to explore the secrets of light and enjoy the beauty of our world. Let's explore the fascinating relationship between the color of light and temperature through the eyes of science. In the previous discussion, we learned how the color of light is distinguished by its wavelength and frequency. However, the color of light is also closely related to temperature. The color temperature of light corresponds to the color of light emitted by an ideal black body radiator at a given temperature. Color temperature is measured in Kelvin, K, units. The higher the value, the bluer the light appears, the lower the value, the redder the light appears. Generally, warm light has a low color temperature and appears red, while cool light has a high color temperature and appears blue. Examples. Candlelight emits warm red light with a low color temperature of about 2,000 K. Fluorescent lights emit light with a medium color temperature of 3,500 K to 4,500 K, giving a cool feel but not fully blue. Noon sunlight emits bright light with a high color temperature of 5,000 K to 5,500 K, appearing blue. Overcast sky emits strong blue light with a very high color temperature of 6,500 K to 7,000 K. The impact of light color and temperature on our lives. Biological rhythms. High color temperature blue light is associated with daytime and activity, helping to wake us up and increase concentration. Conversely, low color temperature red light is associated with nighttime and rest, providing comfort and aiding in sleep. Lighting. Warm lighting is suitable for creating a cozy and comfortable atmosphere, while cool lighting is ideal for a clean and clear feel. Psychology. Red symbolizes energy and passion, while blue symbolizes calmness and tranquility, and these colors are used in interior design and decor. Light and temperature are closely interconnected and have various impacts on our environment. By understanding the scientific basis of light, color, and temperature, we can use them appropriately to create a healthier and more comfortable life. The intriguing relationship between light, color, and temperature. The color of light is determined by its wavelength and frequency, but it is also closely related to temperature. As the temperature of an object emitting light increases, the color of the light shifts towards the blue end of the spectrum. As the temperature decreases, the light shifts towards the red end. This phenomenon is explained by blackbody radiation. A blackbody is a perfect absorber that reflects no light and absorbs all incident radiation. When a blackbody is heated to a certain temperature, it begins to emit light. The color of the emitted light is determined by the temperature of the blackbody. As the temperature increases, the emitted light's wavelength becomes shorter and its energy higher, causing the light to appear blue. Conversely, as the temperature decreases, the emitted light's wavelength becomes longer and its energy lower, causing the light to appear red. This phenomenon can be easily observed in everyday life. For example, when watching a fire, you can see it start with a red color, gradually changing to yellow, and finally turning blue as the temperature increases. This change in color corresponds to the increasing temperature of the fire and the resulting changes in the emitted light's color. Additionally, the sun's color appears different depending on the time of day due to temperature effects. During sunrise and sunset, the sun appears red because its light has to pass through more of the Earth's atmosphere, scattering the blue light. At noon, the sun is positioned higher in the sky, passing through less atmosphere, so the blue light is less scattered, and the sun appears white to our eyes. The relationship between light color and temperature plays an important role in various fields, including astronomy, physics, and engineering. For instance, it is used to measure the temperature of stars or to check the temperature of metals. It is also a crucial factor in the development of artificial light sources, such as LED lighting. Light is utilized in many different ways in our lives, and it is based on fascinating scientific principles. Understanding the relationship between light color and temperature not only helps us comprehend the world around us but also contributes to advancements in science and technology.